All right, we're looking at composition of functions. In this lesson, it goes with our 8.2b notes, and then also being able to state the domain of the resulting power function. So the definition of composition of function is when the function f is composed with the function g, you get a new function, we can call that h. The domain for h is all the x values, that x is a domain of g, and g is the domain of f. So that'll make more sense as we go. Really, we're just going to look at the resulting function and find the domain of that. Watch the order though. If you take the composition of f composed of g, it is not equal to g composed of f. You'll see that the composition of functions is like if you're putting the function g into function f. And if you do it the reverse around, so you put f and you plug it into g, you don't get the same answer. So it's not commutatable. You can't do it back and forth. So just remember that. I'll show you a few examples. Okay, so we'll start out with a couple easy examples with just using linear to show you how composition works. So this first one says f composed of g of x is how you read it. So f is composed of g of x. So f is on the outside, so I start with f. f of x equals 2x. Now I want to plug in g of x where the x is. So instead of x, I want to plug in 5x minus 1 because that is what g of x equals. So I'm taking the function of g of x and inputting it into my f of x function. Now notice I have f of x and 2x. So wherever I had an x, I now replace that x with the 5x minus 1. It used to be x, now it's 5x minus 1. And then you finish simplifying that by using the distributive property. Whoops, forgot to change back to the pen. So 2 times 5x is 10x, and 2 times negative 1 is negative 2. Now this was f composed of g of x, so this is a new function. Like let's call this h of x. This is f composed of g of x, so it's not f and it's not g anymore, it's a new function. This new function has a domain of all real numbers. I know that because I can think about my restrictions. Remember, you can't have any negatives under an even root. So no negative numbers under even roots. So if you had like a square root or a fourth root of x, then your domain would have to be greater than or equal to 0. Also remember that you cannot have any zeros in the denominator. No 0 in denominator. So like if you had x over x minus 2, then x cannot equal 2 because that would give you a 0 in your denominator. So those are our two restrictions. So for the one I did in yellow here, we don't have any roots, we don't have any fractions, so you can plug in any x you want. X is an element of the real numbers. It's all real numbers. Any number you want, you can multiply it by 10 and subtract 2. So all real numbers. All right, number 2. This time it's g composed of f of x. So you start with g of x, which was 5x minus 1. Then you replace the x with f of x. f of x equals 2x. So g, and then you replace the x with the function of 2x. So wherever you had an x in the g of x, you now have a 2x. So I replace the x with the 2x. So when it was just g of x, I had an x right here. When it's g of f of x, I replace the x with the 2x. So I replace that x. And then I simplify that by taking 5 times 2x is 10x. And then it's still minus 1. We're not distributing it anymore. It's just 5 times 2x. And now this is a completely new function. I called this one h. Maybe call this one E, F, G, H, I. How about j of x? But this is g composed of f of x. It's a new function now. It's j of x or something, a different function. And notice how when we did f composed of g of x and we did g composed of f of x, they're not equal. One was 10x minus 2 and one was 10x minus 1. So not equal to do them reverse. The domain for this second one then, all real numbers again. Remember your restrictions. There's no even roots. There's no square roots. There's no fourth roots. So I don't have to worry about negatives under the square roots. And then I don't have any fractions, so I don't have to worry about having zeros in the denominator. So it's all real numbers. All right, the last example, it's f composed of f. So we're putting a function f inside the function f. So f's on the outside, so I'll start with f of x equals 2x. And then I'm taking that function and putting it back in itself. So I'm replacing the x with the 2x. So wherever I have an x on the other side, I now have a 2x. So f composed of f is equal to 4x. There's no even roots, there's no zeros in the denominator, so it's all real numbers. The shorthand writing, if you want to write f composed of f of x, we could write that too. It was f of x, and then it's a little circle, like an open circle. Multiplication is a closed circle. Composition is an open circle. F of x composed of f of x is sometimes how it's written. I'll do a few more. So we have f composed of g of x, but these are our new functions. We're using these. So f's on the outside, so I start with f. So f of x equals 2x to the 1/3 power. Then g of x is x to the 3/4. So if I'm plugging g of x in here, I'm replacing my x with x to the 3/4. Which means on the right side, wherever I have an x, I had an x to the 1/3. So now where this x was, I'm going to put x to the 3/4. Now remember, if you have a power raised to a power, you multiply those exponents. So this is going to be 2 times x to the, when you multiply fractions, multiply the numerators. 1 times 3 is 3, over 4 times 3 is 12. And that can be reduced to 2x to the 1/4. 3 over 12 reduces to 1/4. For domain, think about those restrictions. Remember that the 1/4 power is the same thing as the 4th root of x. So this is an even root. You can't have any negative numbers under an even root. So your domain is going to be x is greater than or equal to 0. I can't take an even root to a negative, or I'm going to have an imaginary answer. So we're going to say that to get all real numbers, our domain will be greater than or equal to 0. G composed of f of x. So this time you start with g of x. So g of x equals x to the 3/4. Now I'm taking the composition of g composed of f. So I'm replacing the x with the function f. So 2x to the 1/3 equals, so wherever I had an x, so I had an x to the 3/4 on the right. So wherever that x was, I'm plugging in 2x to the 1/3 now. And we do have to remember this is a product to a power. So this power has to go to both terms. So this is going to be 2 to the 3/4 power times x, and we get 3/12 again, 3/4 times 1/3. So that's going to be simplified down to 1/4 again. So we're going to rewrite this as a root. They're both 4th roots, so it's a 4th root of 2 cubed x to the 1st, or the 4th root of 8x, because 2 cubed is 8. So this would be how we want to write our final answer. Again, we have an even root, so we can't have any negative numbers under there. So x has to be greater than or equal to 0 for our domain. F composed of itself. Start with f of x equals 2x to the 1/3. We're composing it of itself, so I'm going to plug in 2x to the 1/3 and 4x. I'm running out of room, so I'm going to write that again. So I'm going to have 2. Wherever I had an x, I now have a 2x to the 1/3. So I'm going to have a 2x to the 1/3 in here again. Power to a product, make sure to take that exponent to both here. So I'm going to have a 2 times a 2 to the 1/3 times an x to the 1/9. So 1/3 times 1/3 is 1/9 there. Now when the bases are the same here, these 2's times 2 to the 1/3, I can add the exponents. So remember that 1 is the same thing as 3 over 3. So 2 and then 1/3 x to the 1/9. I have 3/3 plus 1/3 is 2 to the 4/3 x to the 1/9. So there we go there. Domain. The part with the x, this is the 9th root of x to the first. So it's an odd root, so it's all real numbers. There's no fractions here. I could rewrite this a little bit. I'm just going to leave it like that for simplicity. We'll maybe practice how to change this back to radical form. We would have to change this one to ninths. So you'd have to multiply by 3. You'd get 2 to the 12/9 and x to the 1/9. So it would be the 9th root of 2 to the 12th x. Well, then I have 12 2's, so I could take 1 out. And you have the 9th root, 9, 10, 11, 12. So you have 3 2's left. So you'd have 2 to the 3rd left inside. So you have an 8 left, and you have an x left. So this would be the simplified version. There you go. I wasn't going to do it, but it wasn't really that complicated after all. They had to have the same root so I could combine them. So I had to change 4/3 to 12/9. That was the really tricky part. And then 2 cubed left is 8. But I can take the 9th root of any x because it's an odd root. So it's all real numbers for that. So that's composition. Let's see. I'm going to maybe do one more here, maybe a couple more. If you think you got it, you could stop the video. If you want more help, maybe pause it here and try to do these on your own and then see if you can get the answer that I get. So here it starts with f, so f comes first. So I always start with f of x equals 2x to the -1. Then plug in g of x. So I'm going to have x squared minus 1. So I'm going to have 2. And then wherever I have an x, I now have an x squared minus 1. Now remember a negative exponent, that's going to take that expression and bring it down here and make it a positive exponent. So x squared minus 1 to the positive 1 is just x squared minus 1. This is my new function. We could factor the denominator once and say it's x minus 1, x plus 1, since it's difference of squares. It doesn't simplify any further, so you could leave it as either one here. But this one does help me with the domain because I can't have 0 in the denominator, which means that I can't plug in x equals 1 because 1 minus 1 would give me 0, and -1 plus 1 would give me 0. So the domain is x is an element of the real numbers, except for that x cannot equal positive or -1 because you can't have divide by 0. Okay, go the reverse. G of x equals g of x equals x squared minus 1. I'm going to rewrite f of x and make it a positive exponent right away. So it's going to be 2 over x instead of 2x to the negative 1. So I'm going to replace g of x. I'm going to replace the x with 2 over x. So then I have 2 over x for this x, and that's squared. So then remember the quotient rule, square both. So 2 squared x squared minus 1. So our new function, we could call it h of x, is going to be equal 4 over x squared minus 1. Remember domain, you can't divide by 0 again. The only thing squared that equals 0 is 0. So you can't have 0. You can't divide this one by 0. So x is an element of the real numbers, except for that x will not be able to equal 0. All right, f composed of itself. So this time you have f of x is 2 over x. You have f, and you're plugging in 2 over x into that. You're going to end up with a fraction over a fraction. So this was the x. And remember, to deal with that, you actually multiply it by its reciprocal. So you're going to take 2, instead of dividing by a fraction, take 2 times the reciprocal. Then remember, that's the same thing as 2 over 1. So you're going to get 2x over 2. Well, 2 divided by 2 is 1. This whole thing just equals x. For x, there is no even roots, there's no denominator, so it's all real numbers for domain for if the function equals x. So the composition of functions, remember that, watch the order, these are not equal if you do one to the other. This is domain restrictions. So if you're thinking these restrictions, these are when you're finding domain. Otherwise it's usually, so if you have none of these, or maybe I shouldn't say none, if I say you have no restrictions, then domain is all real numbers. All right, thanks so much for watching.